Okay, so if you read through this information, each of the 3 solar panels is 2.7 by 8.9. So all I've done on my diagram is label 2.7 and 8.9. Same here, same here. Now, why have I written area by square metre? Well, I'm hoping if you see square metre, you'd be thinking metres squared. Put that in a circle. And if you're thinking metres squared, obviously that would mean calculate the area. So even before now, you read the question, I'm starting to think I'm going to need to know the area of these solar panels. So at Jupiter, a square metre of solar panel will give 6.2 watts. If we look at the question below then, it says, show that when the spacecraft reaches Jupiter, the 3 solar panels will together give about 450 watts. Well, where's your starting point? As we said, I'm going to start by finding the area of each solar panel. Well, because it's a rectangle, it says at the top, I've just done 2.7 times 8.9, which is 24.03. Now, because I know there's 3 of them, I've multiplied that by 3 to find out the total area of the 3 solar panels, which is 72.09 meters squared. So I know together they're going to cover that area. And obviously solar panel, you know, if the sun can come off it, we can see how much power we're going to generate. So let's have a look at the next question. I know 1 meter squared, which is equal to 6.2 watts. Well, where have I got that from? I've got it from here. A square meter will equal, so it just means if you add a square, which was a meter by a meter, it would give off 6.2 watts. Well, we actually have a lot more of them. We don't have 1, which is equal to 6.2. We have 72.09. So all I've done is I've laid it out slightly differently, but all I've got to do is multiply the 6.2 by the 72.09, because we're generating a lot more than 1, which gives me an answer of 446.958, which would round to 447 watts. Is 447 thereabout? Well, yeah, it says here 450 watts, but the word about means you can assume it would not be exact, and 447 would round to 450 if it was to the nearest 10. Okay, so for this question, slightly different. They're now squares, so we know that these lengths are all going to be the same. There's actually now 1, 2, 3, 4 of them, and because it's in a different planet, they give off different watts, 1.8. So this time it's the reverse. It says for the spacecraft to give a total of 450 watts, what should the length be? So we don't actually know what these are. We need to find them. So I'm going to use my understanding of the last question of how would you find it? Well, if we knew the lengths, we would times them together to find the area, and then we would times that by 4 because there's 4 of them. And once we've got that answer, so the total area of all 4 of these, we'd multiply by 1.8 to give us 450, which is all I've written here. That is how we would find it. Area of the 4 squares times by 1.8 gives us 450. So if we know that, let's reverse it. And by reversing mass, we do the opposite, we go backwards. So 450 divided, I've done the opposites times in, divided by 1.8 gives me 250 meters squared. So I know the 4 squares must add up to 250. So to find one of them, obviously divide by 4, because there's 4 of them. 250 divided by 4 is 62.5. So that means each square will now be 62.5 meters squared in terms of their area. So I could write that on all of the squares at the top. So now I want to find out how big must each length be. Well, then there's got to be the same. So something times something has got to give me 62.5. Well, I've shown that by here. Hopefully you know what is the opposite to times in the same number by itself. Well, the opposite to doing that is doing the square root. So the square root of 62.5 will give me the answer of 7.9056, etc. So rounded to 1 dp would be 7.9 meters. It doesn't actually say what to round it to. So as long as you've got this answer, and then if you've rounded to 8, that's fine. Where will the marks come from? Well, if you found out each square is going to be 62, that's your second mark. The first mark would be for 250. Okay, if you've got a diagram, let's use it. They start 1 kilometer apart, which is exactly the same as 1,000 meters. So hopefully you know the distance between here and here is 1,000 or 1 kilometre. Right, why have I taken away 3? Well, the robots move towards each other, so one is going this way, the other is going this way, and meet at 7. They started at 3, they meet at 7, so we know it takes a total of 4 hours. So if you've got 4 hours, you're going to get a mark already. Alright, now let's work out the next part. Robot A moves at a speed of 0.15 kilometers per hour. So because this is already in kilometers per hour, we don't need to be dealing with meters here. We could just keep this as 1 kilometer instead. Everything's got to be in the same units. What constant speed does robot B move at? Okay, well let's start first by finding out how far would robot A travel at this speed in 4 hours. So what have I written here? Robot A will go 0.15 kilometers in an hour. So how do I find out how long he'll go in 4? Well, I just times by 4, which is 0.6. So robot A is actually going to go 0.6 kilometers. Well, if robot A has gone 0.6, what's left for robot B? 0.4, because they've got to add up to 1, which is what I've done here. 1 kilometer take away 0.6 is 0.4, so that's how far B has to travel. Well, how long is that going to take? Well, we know it takes robot B 4 hours, which means they're traveling a little bit slower. 0.4 kilometers in 4 hours. So to find out the speed, we have to compare it in 1 hour. So I've done 0.4 divided by 4 to take me down to 1 hour, which gives me a final speed of 0.1 kilometers per hour. If you had 0.4, that's your second mark, or your final mark for 0.1. Okay, I've seen something like this come up in a GCSE question, but it's actually quite nice. All you got to do is take off 10% from 50, but it's all about the reading. Because it says then, you've got to use that new answer and add 10% on, not add the 10% on which you've already taken off. So, what have I done? Let's have a look. 50. Well, how do I find 10% divided by 10? Is 5. Taking it off. 45 quid. Lovely. But I've now got to find 10% of that, not 50. So, what am I going to do now? Well, 10% of 45 is actually £4.50. It's a little bit less. If I add that £4.50 back on, it takes me to £49.50. So are they equal? Well, quite clearly it's not. £49.50 is 50p short of what we started with. So no, 50p short. You get 1 mark for finding 10% correctly. And then the 2 marks for finding the new 10% and proving it. Okay, next question. All sorts of ways you can do it, but let's try and find the most efficient. The perimeter of the rectangle is 72, so that's all the way around here. The rectangle is cut in half to make 2 squares. Work out the length of one side of the square. Well, by putting these 2 squares together, which shows that here, you remove these 2 sides. So by removing these 2 sides, how many of these sides are you left with in the rectangle to start with? Well, 1, 2, 3, 4, 5, 6. So all I've got to do is divide 72 by 6, and that will tell me how big each length on the square is. So you could have done it different ways, but that's definitely the most efficient. 72 divided by 6 is going to give me the answer of 12. So nice and easy. If you've shown 6 sides, you'll get a mark, and then for the final answer of 12 centimeters, you get your second mark. Okay, next one. Write the 2 numbers that multiply to make minus 10. Well, if we ignore the minus 10, 2 times 5, 1 times 10, they're 2 numbers that multiply to get to 10. But they've got to add to make to 3. Well, which ones here have a difference of 3? Well, these have a difference of 3. So we know it's going to have to be 2 and 5. But the only way you can make a minus is by making one of them negative and the other one positive. So, how will I make a positive 3 by having a 5 and a 2? Well, 5 take away 2 will take you down to 3. So your 2 numbers are minus 2 and 5. Okay, for this question, I found it easier to just choose a number. So I've written here, choose number and find the mean. So I've said a red book is 10. And then because a blue looks smaller, I've just said a blue book is 5. And then I've simply found the mean. Well, how do you find the mean? You add them all up and divide by however many there are. So I will add 10, 10, 5, 5, 10, 5, 5, 5, 10, 10 for this one and divide by however many are there. And then I'll do the same for this one, but I'm just going to use the number 10. So pile W, let's have a look. Well, pile W, as you can see, has 5 red books, 5 blue books. So I've added them up, 50 and 25. So 10 books in total, maybe I'll draw a line into there, gives me 75. So how do I find the mean? Well, 75 divided by 10 is 7.5. We're now going to do the same for pile Y. 1, 2, 3, 4, 5 books. And they're all 10, so that would add to 50. 50 divided by 5 is 10. So 10 is quite clearly bigger than 7.5. So if you've used numbers, you'll get 1 mark just for that. But your 2 marks are for your reasoning. Well, why does it make sense? Well, Y has a bigger mean because there's less books. The less books you need to share, obviously, when you're dividing them together, you're gonna have a bigger number because you're sharing it between less people, or in this case, books. Okay, so for this question, Y has the blue line, which says is added. Why is he on a perfect straight line? Well, if this is where traffic lights are, then obviously if it's going in a straight line, it's not touching them, he doesn't have to stop. Now you can see I've already answered the next one, but let's see how I've done it. I've put the line must be the same steepness. Why the same steepness? Because he's going at the same speed. So that is also known as the gradient. Show how Hugh's route accurately on the same graph. Show his route accurately and remember how you must not walk when the lights are red. Well, if he's left a minute after him, you've got to start at 1. Okay, 0 and 1. Now, going at the same gradient, that would take me to here, but then I have to stop because the light is on, so you have to now wait. So if you're waiting, you go across until it changes. Again, I've got to go exactly the same gradient. Effectively, it should be parallel between these two. But then I've hit the red light again, so I have to wait, and eventually you should finish at 3.5. Okay, so 2 marks available here, or 3 rather. 1 mark for the first part. Second mark is for making sure you stop in the middle of this red light, and your third mark is for finishing at 3.5. Then, how many minutes after added did Hugh arrive home? Well, this is where Hugh arrived home, this is where added arrived home, so you've got to find out the difference between here and here. Well, this is at 2 minutes. Sorry, if you see, this is at 2 minutes. So half a minute, 1 minute, half a minute. So 1.5 minutes, which is also 1 minute and 30 seconds for your 4th mark.